Welcome everyone to the Black Belt session. Go ahead. So I'm very pleased to welcome Chris Crone from the Docker Paris office. He's a tech lead on the app definition team, and he's personally responsible for the keynote failure, the demo failure at the keynote yesterday. So yeah, he's going to talk about extending Kubernetes, the experience from their team. So give it up for Chris.
Hi, everyone, and welcome to the talk. Thank you for coming. Yeah, that was my team's stuff, so that wasn't great. But we've got the logs, we'll debug it. So today we'll be talking about extending Kubernetes. Our team is in part responsible for composing Kubernetes, so we have experience with CRDs and API aggregation, and we just wanted to share some of that with the broader community. So who am I? I'm Chris Crone. I'm an engineering manager at Docker, and I'm the tech lead of the application definition team, where we have people in Paris, Cambridge, and San Francisco, so we're a distributed team. We're responsible for things that include Docker app, which you saw, Docker assemble, written by Ian Campbell, who's also here, I can see, and composing Kubernetes, as well as Compose, which is maintained by Joffrey. I'm sure if you've looked at the repo, you'll have seen that. So what will we be talking about today? Today we're going to be talking about what is composing Kubernetes, why did we build it? We'll be going more generally towards Kubernetes in terms of how do you extend it, why would you want to extend it, what extending Kubernetes means. We'll talk about our experience of building a CRD and then migrating to an API server, so API aggregation, and why we did that. There are going to be 2 demos where I'll show you why and how things work. And then I'll give you some recommendations about what I think you should do if you're going to write an extension for Kubernetes now. So to start with, to explain Compose, we need to understand what an application is. So we think an application is 3 things. It's some metadata, a component list, and some parameters. So the metadata is things like the name of the application, a version, a description, things like that. A component list is a way of describing the bits that make up the application. So for us, it's mostly Compose, but kubeyaml does the same thing. It could be a typed language, could be anything. It just needs to describe what makes up the application. And finally, parameters are deploy time parameters that you may want to change. So things like ports, labels, secrets, things like that. So it's things that are not part of the application, but an operator would care about them. So Compose in that schema is the bit that allows you to describe the components that make up the application. So here we can see we have just a simple 2-service compose file. This is the black belt track. I think everybody has this handled, but here we have a bunch of components that are described by this file. So we have 2 services, as you can see here. We have DB and MyApp. We have port mapping over here, which maps port 80 on the containers to an external port of 8000. We have a volume here for the state of our DB, which is attached to the DB container. And then we have a replicas 2 over here, which says, okay, well, we want 2 of these MyApp containers to make up that service. So that's kind of the role that Compose plays. For each service, you need at least 1 image. That's the absolute minimum, but then you can add a bunch of other settings depending on what you want to do. So Compose is simple. This is why we like Compose. Even if you've never seen Compose before, looking at something like this, you kind of know what's going on. In this case, we have 2 services. It's quite clear. We have 2 volumes. We have something called environment, and it looks like they're environment variables. You know, it's very easy to read this. So this is a really good format for describing that component list. Kubernetes YAML is comprehensive. It's extremely powerful because it gives you direct access to the Kubernetes API. But it requires underlying knowledge of Kubernetes to make it work. So it's also extremely verbose. If you take the same application and describe it in Kubernetes YAML, it'll probably be about 5 times longer than Compose. And that's not only a problem when you're developing, that's also a cost of maintenance. Because if you have more YAML, it just means there's more to maintain, and there's more that can go wrong. So all this has made Compose extremely popular. There are more than 425,000 public Compose files on GitHub, and it's doubling every year. So it's growing quite quickly. So, composing Kubernetes, why did we do it? Well, there's lots of Compose files that exist already. Lots of companies already have it, and they're using it to deploy their applications. So why not leverage what people have already written and what people will write for the reasons that Compose is great, and allow people to deploy them onto their Compose applications onto Kubernetes. So it's part of Docker Desktop and Docker Enterprise, which are both certified Kubernetes distributions. That means we don't make any forks and things. It's genuinely pure Kubernetes. It can be deployed, so you can install Compose on Kubernetes on any Kubernetes cluster now that it's open source. The one caveat there is it needs to support API aggregation, which is an option, and I don't know if all of the cloud providers support that at the moment. Last time we checked, I think EKS didn't. And as you saw Kel announce earlier today, Compose on Kubernetes is open source, so you can go to that repo, and I'll have it up later, don't worry, and you can check out the code and play with it. So let's now take a look at Kubernetes resources, because how do we implement this Compose on Kubernetes thing? What do we do? So if you've ever used Kubernetes, you've used some sort of resources. There are a bunch of native ones, things like pods, deployments, load balancers, headless services. You've all seen those. There's around 50 of them. They are all accessible via a declarative REST API. Declarative means you declare the state you want, it stores that, and then it tries to reconcile the state of the cluster to that. It stores these objects, as I said, in somewhere, and it's an etcd for Kubernetes, but it could be any distributed key value store. And then you have these controllers that run inside Kubernetes, which are simply Kubernetes clients that watch the state of the cluster and try to reconcile that with the desired state. So we talked about this declarative REST API. This is what a Kubernetes REST path looks like. First we have the group over here. So this is the path for a deployment. So we have a group, a version, and a resource. The group makes it easy to extend the API, and I'll dive into this a bit later, but it's important for the extension part of it. The version allows you to version your API, which is good practice and makes your life a lot easier. If it's an alpha, it means that it's not active by default. If it's beta, it's active by default, but it's not recommended for production. Stable is obviously recommended for production and active by default. In practice, the beta APIs of Kubernetes are actually quite stable. Finally, we have the resource, and that's just the name of your new thing. So if we look at how Kubernetes works when you create a deployment and we follow the flow, you'll get a better idea of how all these things work together. So if you have, in this case, we're going to do a kubectl create with a deployment YAML. This you can literally run on your computer right now, and this is what will happen. So in this case, kubectl is a REST client. It does a post onto the Kubernetes API server with the desired state of this deployment, which then simply stores that state into an etcd. We have a controller running inside the Kubernetes cluster. And as I said, this is just a Kubernetes client that either polls the cluster to get the current state, or it sets up watches to watch for specific changes. It sees this change because it's been watching for new deployment objects. And so it reacts. And how does it react? It just creates objects on the Kubernetes API server. So, as it's just another Kubernetes client, it's just doing REST posts to do that. So at the end of this process, after your kubectl creates, we now can do a kubectl get all, and here you go. We've created that deployment that we can see up there, but actually that's created a replica set, which is then in turn created a bunch of pods that it owns. So you can see how the controller has taken ownership and made those other objects. So what do we mean by extending Kubernetes? Well, you can add your own resources to Kubernetes. So that means you can add new REST endpoints and new kinds of objects to Kubernetes. There are two ways of doing this. There's a CRD and API aggregation. Kubernetes was built to be extended. So in the case of a CRD, this is the simplest case. And how a CRD works is it's just like any other object. A CRD stands for custom resource definition. You create a CRD as you would anything else. So you can do a kubectl create or kubectl apply to create it. And what that does is it tells the API server to register a new kind. It then handles the storage for you and creates the REST points for you, so you don't have to do anything. You can then have an optional controller, which will then reconcile state based on what you store. You don't need a controller. If you just want to store data and be able to get it back, you can use a CRD with no controller. It's completely optional. The second form is called API Aggregation. Now, this is a bit more complicated, but it gives you a bit more flexibility. So the Kubernetes API server just forwards all the requests inside a group to your custom API server. So you have to write a new component called an API server, and that component then registers itself with the Kubernetes API server and says, if you receive anything on the slash, send it to me. So this is where the group becomes important. Once again, you can have an optional custom controller if you'd like. If you don't want to just store things, if you want to be able to reconcile and do other work in the background, you can do that. The other thing to know about this API server, this custom one, is that you need to handle the object storage, which means if you have an etcd, you need to have certificates and things like that to access it. So it requires quite a lot more work. Specifically for the certificates, you probably need some kind of custom installer. So it's not as easy as a kubectl create. It's probably some custom binary. So we'll start with a quick demo then. I'll show you quickly how to make a CRD. Let me just switch the screen. Oh, so I'm going to mirror my display. There we go. All right, so we've had bad luck with the demo so far, but this should all work. So what I've got running right now, I'll just show you, is a simple kube cluster. I'm using Docker Desktop Enterprise because it allows me to switch my versions of kube and the engine really easily. So I've got a simple shell script here which is going to run through the demo. It's a real demo, I promise. So as I told you, a CRD is just another Kubernetes resource. So you can use kubectl to manipulate them. So in this case, we'll get a list of the CRDs that are already installed in my cluster. Yeah, there are none, which is good. So let's take a look at what a CRD would look like that we could apply to this cluster. So here's a simple YAML file. We've got an API version. So this is the endpoint we're going to be hitting when we do the REST post. It's apiextensions.krds.io/v1b21. It's of the kind custom resource definition. It has a name. We're going to name it foods.example.dockercon.com. And the spec is now the data we're going to be giving to Kubernetes that will create the CRD. So we're going to name our group. You remember the group from the REST path. It's going to be example.dockercon.com. We're going to give it a version, v1 alpha 1. It's going to then have, we're registering the type foo with the plurals foos. And it'll be namespaced. What namespaced means is if you've ever used Kubernetes, you know you can specify a namespace when you deploy a pod or a deployment. When you declare a CRD, you can say if your object is namespaced or not. So, because some objects are not, they're global. So we're going to run a kubectl create -f and pass it exactly that file. And that created it. So there we go. We got the standard kubectl create response. So now if we list the CRDs, what we're expecting to see is our CRD. And there you go. So it's created, and you can check the timestamp. So because we've added a new kind to Kubernetes, it's a native Kubernetes object, which means you can manipulate it using kubectl. So what we can do now is we can say, well, I registered the plural of foo as foos. So if I get foos, well, we don't have any yet, but we can do it. So that's great. We didn't get like a command not found or something like that. So let's take a look at a quick object. So it's a kind foo, because remember we registered the kind foo as the new inside the CRD. My API version includes the group and the version that I declared. Metadata now, so it's the name of my foo. It's going to be bar. And inside the spec, we're just going to put 2 keys and 2 values. That's it. So let's apply this to the cluster. So we're going to create this. And there we go. It's done. Now if we get the foos, ta-da, we have a bar. And as I told you before, you can interact with these objects as you would any other Kubernetes object. So we can describe our foo bar. So here we go. And you can see the name. It's in the default namespace because we didn't specify a namespace. I didn't specify any labels or annotations, which you can also add because it's like any kube object. We have inside the spec, we can see the key 1, key 2, value 1, value 2. So everything's great. We have this object inside our cluster. So let's create another one. Once again, foo on the API version example.dockercon.com/v1 alpha 1. We're going to give this one a different name. We're going to call it Baz. And you'll notice now that I'm only giving it 1 key. So this is one of the catches with using CRDs, is that especially with older versions of Kubernetes, there is no payload, or there was no payload validation. So that's been changed, but you'll see what happens now. So when I create this, it creates. There's no error, nothing, even though the keys are not the same as the other one. If we list them, we have 2. And if we describe BAS, it only has 1 key. So that's a demo. So we've stored something inside our Kubernetes cluster. It took 2 minutes. We created a CRD, and we stored 2 objects inside our CRD. Right. So custom resource definitions are extremely easy to implement. It does all the work for us. We didn't have to do any REST endpoints or anything like that. It handled the storage for us. It was great. However, we have limited flexibility. Because we didn't create the REST endpoint, we can't control which sub-resources or other things are present there. We also have limited validation of REST payloads. As you saw there, I had two different payloads, and there was no error. It just returned a 200. And that becomes a problem when you start doing reconciliation with the controller, because if there's an error, you only catch it inside the reconciliation loop, and that's difficult for users to use. So API aggregation, on the other hand, we have complete control over the REST endpoint, because we created the REST endpoint, and Kubernetes forwards everything inside that slash to us. That means we can do custom validation, because we can get the payload and validate it ourselves, and we can do sub-resources. So for example, if you have an object and you want to have a sub-resource of that object, you can do that if you'd like. However, it's much more complicated because it's an extra component, which adds risk, and you probably need a custom installer to handle certificates and things like that. So initially, we made Compose on Kubernetes with a CRD because it was quicker and easier, and it did what we needed it to do. We demoed this at DockerCon 2017 at the EU one in Copenhagen, and we targeted Kubernetes 1.8. So Kubernetes evolves quickly. When I made my slides, it was 1.12. It is now 1.13. A lot has changed in the last 5 releases. What we discovered in making Compose for Kubernetes, or Compose on Kubernetes, is that reconciliation loops are great for distributed systems because they make the logic a lot simpler. The machine logic behind the scenes is really simple, but they're bad for user experience because every error or a whole class of errors is only exposed in reconciliation loops, which means you need to read logs, or I can give you the classic example. We've all done this. kubectl apply, my app, deployment created, great. Return to 0, that looks good. We do a kubectl get all, and we see something like crash loop backoff. Then we do a kubectl describe or a kubectl logs on our object. We edit our application and reapply it because there's some error. And so what we would like to have is when we do that initial create, we would like to get an error back. We don't want to have to look for errors inside logs. So the composing Kubernetes architecture is as such. As I told you, we have now moved it from a CRD to API aggregation. So here we have the Docker clients, or the Docker CLI is one of the clients, kubectl is another. That interacts with the Kubernetes API server via REST, which forwards all the requests inside our compose.docker.com group to our Compose API server. That then stores the state inside, or stores the desired state inside etcd. And then we have our custom Compose controller, which watches the Kubernetes API server for events that impact stacks, and it reacts accordingly. So for example, if it sees a stack creation or a stack that doesn't have objects yet, it'll create those objects. If it sees that an object was manipulated, that is part of a stack that it's maintaining, it'll clean that up to make sure that we always reconcile the desired and the current state. So as I told you earlier, one of the reasons we moved to the API server model is because we have full control over the endpoints. So we can do the custom validation, and we can do things like adding a /logs sub-resource. So for example, wouldn't it be great if you had a REST endpoint that was just /logs on the end of your stack name, and it returned all the logs to you, or scale, or status, or things like that. So the move from the CRD to API aggregation was painful. You can't have 2 extensions using the same API group. So that meant we had to do a migration. And we had already shipped this to customers, which meant we had to do a live migration. So the process we had to follow for this is that we had to stop the controller because we didn't want the controller to change the state. We installed a backup CRD because all we want to do here is store the existing stacks. We then copied the stacks into the backup CRD, uninstalled the old stack CRD, installed the new stacks API server, restored the backup, started the controller, and then removed the backup. We had to do that as well because we changed how we store stacks. We used to store the compose file as part of that. We don't anymore. So it was rough. Don't recommend it. So here's another demo. So I'm going to show you composing Kubernetes, how it works, and why we did it. So I'm going to show you some of the bits and bobs. So as we announced earlier today, composing Kubernetes is now open source. I'm just using the open source version here. You can see I'm using, I have my own branch, but it's on docker/compose on Kubernetes. To install the debug version, we've got a nice tool. If you just do this, I'm not going to do it now, I don't want to break anything. It basically installs a debug version of composing Kubernetes to your Docker desktop. So this is what we use to debug, which is what you should probably use too. I'll make my slides available as well, so don't worry too much. What I've got open here as well is I've got the logs from the compose controller, so we can see how the compose controller reacts as we do things. Right, so one cool feature that was added to kubectl in 1.12, I think, is API resources. So this allows you to see which API resources we have available. So you've got name, short name, API group, namespace, so that was if the object is stored in a namespace or not, and a kind. And as you can see, there are a bunch of them. So I'll just grep for the stacks one, because what we've done with composing Kubernetes is we've added a new kind stack. So as you can see, one of them is that. And our group, as I told you before, is compose.docker.com. So let's have a look at the running components of composing Kubernetes. On Docker Desktop, we store them inside the Docker namespace. So here we can see we have two pods running. Well, yeah, two pods running. We have the compose pod and the API pod. The compose pod is the compose controller. The API pod is the compose API server. We have some services there that are used for debugging. We have a nice live debug option where you can use Delve to do live debugging. It makes it a lot easier because debugging this is no fun. So those two services are just exposing debug ports. They aren't normally there if you use the production version. Then we have two deployments, the compose deployments and the compose API one, which correspond to the controller and the API server. So let's have a look what else is running in my default namespace. Right now there's nothing, we just have our standard Kubernetes service, which exposes the kube API internally. Let's look at a simple compose file. So here we go. It's a 3-service one. You've seen this one 1,000 times at the last, I don't know how many DockerCons. We have a DB, which stores a bunch of words. We have a words backend, which fetches words from the DB, and each one will fetch a different word. And then we have a web frontend, which exposes that. So as I showed you before, the Docker client is simply a REST client in this case for the Kubernetes API server. So we can do a Docker stack deploy, target the Kubernetes orchestrator, give it a compose file and a name, and it'll go. So what we can see now, you can see it's a real demo, we have the compose controller reacting to this. So you can see that it's watching the deployments, or it saw the stack create. It's watching the deployments and watching as pods are created to ensure it can tell us when the stack is available. A stack is completely available when it's completely reconciled. Right, so we got that running. So if we do a kubectl get all now on the default namespace, we will see that we have 5 pods with words, 1 web, 1 DB, a bunch of services. So we create a headless service for every Swarm service or every service inside of a compose file. That allows us to do the DNS stuff, because if you've got an application that, for example, uses the hostname DB to access your DB, it works with compose and Swarm. We wanted to make that work in Kubernetes as well. So we use headless services to do that. We also have the web published service. That's a load balancer type, so that exposes it externally. We have those 3 deployments, one for each service. We use a deployment if you don't have volumes attached, otherwise we use a stateful set. If you define a global service, we use a, what's it called, a daemon set. Right, so let's see if it's working. If we open up localhost 8000, if it's going to, oh, I think it probably opened it on one of my other screens, sorry about that. I don't know if I can, let's see how this is going to work. Well, there we go. Right, so there you go. So we have 5 words up there. We can see that each of these comes from from a bunch of different pods. We have 202, 203, 204, 202, 203. So we're hitting 3 of the different pods in the service. It's doing DNS round robin. Yeah, there you go. So how would you scale this compose or this stack? So let's say we want to add 10 replicas of the words. Well, we can apply another compose file. So here we just have the same one, except now we have replicas 10 instead of replicas 5. We do a Docker stack deploy as you would in Swarm. And if we look at the controller, we'll see it's reacting. So now we see deployment words has 10 of 10. That was quick. So if we get the deployments, we see what we expected because we changed the number of replicas. As I told you before, we're not just hacking something in Kubernetes here. We're actually extending the Kubernetes API. We've added a new kind, a stack with the plural stacks. So we can do a kubectl get stacks. And there you go. So we have some rich information back about the stack. We have the name, we have the number of services, we have which ports it's exposing externally, we have its current state, so it's available because everything is ready, and we have a creation date. We can also describe it as we would any other Kubernetes object. So here we have the name, the namespace, labels, annotations, all the classic stuff. Inside the spec, that's where it gets interesting. So we serialize the compose file, or we pass the compose file and create a struct. Here is that struct. It's in the spec. So here you can see the 3 services. You can see some information about how we expose ports, the number of replicas, things like that. And of course, the status. So one of the other reasons we use an API server is we can add custom endpoints, or custom sub resources. So here I've got just to avoid having the HTTPS issues or the certificate issues, I've just started a kube proxy on my 8080 port, and I'm going to curl into localhost 8080 APIs compose.docker.com. That's our group version v1 beta 2 namespaces default stacks. The name of my stack, which is demo stack, and then scale. So scale is a custom sub-resource. And so here we got the scale information back. So in this case, we can see how many, the spec tells us the desired state, the status tells us the actual state. And we can query that for every resource we create. So the other reason I told you about that we did this is because we can do custom validation. So what I'm going to try and do here is deploy the same compose file, but with a different name. And what that'll do is it'll create services and deployments with the same names. So instead of applying it to the cluster and waiting to see that nothing works, what we can do is we can say, hey, you tried to create a stack, but it has these naming conflicts, and it returns an error directly to you. So that's a way better user experience than doing a kubectl logs on things to understand what happened. One of the questions we get asked is, why did we implement this with components on the server side and on the client side? So if you do everything on the client side, it's a fire and forget. If somebody changes something, you can't reconcile it, and you don't know what will happen to it in the long term. If you have server-side components and you store the desired state in the server side, you can handle people breaking things because it'll repair itself. So in this case, an operator comes along and he tries to scale the words deployments to 5 replicas. Remember, we set it to 10 inside the stack. Well, it scales. If you look, our compose controller has reacted. It said, oh no, you killed my pods. I'm going to reconcile that back up to 10, which is done. And so now when we get our deployments, even though that they've just attacked, well, they just hit the deployments and made it 5 replicas, it's back up to 10 because we've reconciled the desired state and the current state of the stack. We don't care about the deployments. So as I told you, we originally did this for Kubernetes 1.8, and that was a long time ago, or what feels like a long time ago. A lot has changed. In Kubernetes 1.12, we now have a validation of payloads with Open API v3 schema, so you can do types, you can do strings, string regex, you can do integers, minimum, maximum, things like that. It is quite powerful. You also have the ability to define a status and a scale subresource. So you can't do any subresource, but you can do a couple. So even though this is better than what we originally started with, it's still not quite as powerful, or it doesn't solve all the problems we had with composing Kubernetes. So what are other people using? This is a good starting point if you're planning on doing this. There's about 6,000 CRDs that I could find on GitHub that are public. And speaking to the Kubernetes guys, they said there are about half as many API aggregation or API servers. What should you use? Probably a CRD. More interesting features are being added with each release. The goal of the Kubernetes team is actually to make this, to push people towards CRDs just because they're easier for everyone. They're simpler to build, easier to maintain, just better in general. Maybe API aggregation. If you want full control over REST endpoints, or if you want custom validation, you have to go that way. So as I told you before, this is the black belt track. You should get the source code. You should check this out. You should hack this. It's on Docker, on GitHub at docker/composing Kubernetes. We're also hiring. So this was built by people in Paris and Cambridge mostly. So we have two offices. We have one in Paris, one in Cambridge. I'm based in Paris, and I have colleagues around Europe. We are responsible in our group for Docker Desktop, Docker App, composing Kubernetes, and a bunch of other things. So we're doing real engineering work. It's really cool. Yeah, so I open that up for questions if anybody would like.
Thank you, Chris. Here's a microphone for questions. So we have a couple of minutes. If you have some questions, you can come and line up here. I think it's on. Yeah.
Yeah, hi. One question is, like, I have seen that when you expose a service in a Docker Compose file, it will become a load balancer type of service on the Kubernetes side.
Yeah.
So there are different reasoning about using a load balancer type of service or an ingress. Because, for example, on GKA, it costs you much more. If you create a load balancer for each exposed service, that's probably, maybe you hit some limits with available load balancer on the Google side and costs you more if you are using an ingress type. Is it something that you can configure, or I have to change code?
So we have when you install the Compose controller, you can specify what type of network service you want to create. So we have the option of node port or load balancer. In Docker Desktop, we use load balancer just because it's more friendly. Node port has to be in a specific range, and it's up to the operator to make sure that port is free, or else it'll just fail in loops. So on UCP or in Docker Enterprise, we do node ports because we can't guarantee that there'll be a load balancer there. So Kubernetes has this weird relationship with networking where they kind of say, it's your problem, which means that it's really difficult to be a developer building things on top of Kubernetes because you don't know what the networking is going to be like.
Is it possible to use cluster IP type of services?
Cluster IP? For what would you want to do that?
Because that would match more like if I would create ingress.
I think you're looking for node port. So what node port does is it opens up, no, not, okay. All right. Yeah.
Yeah, I work with Chris on that project, and actually I'm Simon Ferkel at Docker Paris as well. So one thing, we do not support yet ingress controller because at the beginning we were targeting UCP and we don't ship any ingress controller out of the box, and yeah, so we couldn't make something opinionated, but. Lately, what we begin to introduce is a kind of service creation strategies that you can configure on the Docker Compose level. And what we expect is that we will get help from the community to work on that subject, because I think it's a great idea to be able to expose services as with an ingress controller. the challenge is making it in a way that works with every single ingress controller, and yeah, that's the main issue. And although we don't support only HTTP or HTTPS endpoints, we support any TCP or UDP endpoint. So it doesn't make sense for us to restrict services to something that only can be HTTP or HTTPS.
Okay, thanks.
Yeah, so it is open source and contributions are welcome. So open source from this morning. There are instructions to install it in a debug way. We'll add better documentation as we go forwards. Was it technical enough?
Any other questions?
Yep.
Please go to the mic. Thank you.
Is the API server to the ETC only to the ETC resources of its own namespaces, or can you also share it or have some policies inside?
It might depend on the certs, but Simon will know more about that.
Yeah, actually, the etcd instance that the Compose API talks to is can be the same as Kubernetes one, but it's not mandatory. And actually, we are prototyping things so that you can deploy on manage Kubernetes like GKE or AKS. And in those environments, we can't access the etcd server, so we spawn our own. And actually, you have all the rights you can get from your particular client certificate bundle against your etcd cluster. So we are not scoped as the objects. We are not scoped at all from our review of on the etcd cluster.
You mentioned that the stacks will have precedence over the deployment when it comes to replicas, for example. Mm-hmm. So how would that work with a horizontal pod autoscaler?
So at the moment, we don't support them. We thought about adding something to Compose, because what we want you to do is describe your application in Compose, because that's a bit more manageable than Kubernetes YAML. So the correct way we think to do that would be to add something to Compose where you can say, I want this to scale horizontally, and then the controller will react accordingly. So it's something we've done lots of POCs with and we've been playing a lot with, but we need to work out a good way of exposing the rich Kubernetes features in a way that is useful for operators. So we're still working on that. Yeah.
And we have like 3 more minutes if you have questions. Otherwise, we'll close once, twice. All right, well, thank you very much.
Yeah.
Please give a warm applause.